So we're going to be talking about in our packet how to work out number 12. Number 12 says y equals negative and then 2x minus pi over 4. We're really familiar already with how to find the amplitude here. What would you have for your amplitude? Again, you guys are used to saying the negative one. I'm going to say that my amplitude is just a positive one. And the negative, I'm going to remind myself maybe somewhere that I'm going to do the inverse later. So that negative does not mean the amplitude is a negative. The amplitude still goes up one from your midline and down one below your midline. But it's that instead of having our sine curve go up and then down, our sine curve will go down and then up. So it's a sine curve that's inverse. Yeah? You could put a negative one. I will not count it off. I would not count points off. No. How about a vertical shift? Do we have it moving up or moving down? Is there something added outside parentheses? No, that minus pi over 4 does not move it up or down. It actually moves it left or right. So our vertical shift is 0. So our first two things that we're worried about here, we're fine. Now be careful. We can't just say our phase shift is pi over 4. We have to have the coefficient factored out first. And I picked a really tough problem. We haven't done one like this before, but I did it on purpose. So what we need to do is we need to look at, and I'll do it right over here, this 2x minus pi over 4, we're taking the sine of, and we need to factor out the leading coefficient. We need to factor out the 2. So if I factored out the 2 here, what would I have left? When you factor out the 2, just to remind you, what you're really doing is you're dividing by 2. What is pi over 4 divided by 2? All right? It's actually pi over 8. Ah. We had an so what I said to you, I am taking pi over 4 and I'm dividing it by 2, or if we thought of it as dividing by 2 over 1. That's the same thing as taking pi over 4 and multiplying it by 1 over 2. That's how I got pi over 8. So here, what we really have for our problem is y equals negative 1 sine of 2 times x minus pi over 8. So our phase shift is positive pi over 8. Why did I make it a positive pi over 8 when we're subtracting here? Opposite on the inside of our parentheses. So our left-right shifts are in oppositeville. Our period, now our coefficient here, our k, is 2. So for the period, we need to say what is 2 pi divided by 2. So our period would be pi. So we're going to deal with the phase shift in a minute. Don't even write this down yet. I'm going to show you kind of what our curve would look like, and then we'll kind of figure out the phase shift. How did I find out the phase shift? I had to factor out the 2. All right, so what I first started with is I factored out the 2, and I kind of did that over here. I talked about how I got that when I factored out the 2, I really had 2 times here x minus pi over 8. And factoring out the 2 meant dividing by 2, and I showed that right here. All right, that I was dividing by 2 right there. And then I rewrote it with everything factored out. So what's in the parentheses is my phase shift. That minus pi over 8 is my phase shift. And the outside the parentheses, or what's multiplied by it, is my k, which has to do with my period. So usually a negative sine curve will do this. That's usually what our negative sine curve does. Our phase shift is basically saying take this and move it over. 1/8. All right, or pi over 8. And we could do that. And it used to be that we used to have you graph it that way. All right? So instead of being here, we're just over a little eighth everywhere. But it gets messy depending on how big of a phase shift. There are times that you have a phase shift of 5 pi, and so we might be off the graph, or it's really hard to graph them all. So instead of showing and kind of, you don't have the ability like I do to move your curve to the right or to the left. What we are going to be doing is we're going to keep it on our axis, and we're going to change what our axis is. So I want you to indicate that instead of starting at 0 here, we usually start at 0, we're going to start at pi over 8. So our phase shift changes where we start. So you need to indicate that you start at pi over 8. Now, our cycle needs to happen in pi radians. This cycle right here needs to happen in pi radians. So I need to get here in pi radians, but I didn't start at 0. I started at pi over 8. So right here, I started at pi over 8, and I need to add pi to it. So what would that be? I started it basically at 1/8, and I need to add 1 to it. Where would I be? 1 and 1/8. Another way to show 1 and 1/8, 9/8. So I'm actually at 9/8 pi. I would want to know where halfway is. Is there a quick way to figure out what halfway between 1/8 pi and 9/8 pi is? Anybody know of a quick way? What if I took 1/8 plus 9/8 and then divided it by 2? 1 and 9 is 10. 10 divided by 2 is 5. Halfway is 5/8 pi. So what I just did is I said this is really like 9/8 pi, 1/8 pi. Halfway between the 1 and the 9 is 5.
How did you get 9/8 pi?
All right, how did I get 9/8 pi? Someone had said it's like 1 and 1/8 pi is what they said. They said, oh, it's like 1 pi and 1/8 more because we shifted it 1/8. So in my head, I went, oh, 1 and 1/8. I went 8 times 1 is 8 plus the 1. This is the same thing as 9/8. That's how, and the fact that we have pi is just kind of there. That's how I got the 9/8 pi. Okay? So, halfway here, and I want you to find all 4 of our kind of checkpoints. Halfway between 1 and 5, all right, is 3. So we'd put 3/8 pi. Halfway between 5 and 9 is 7/8 pi. Now, the last thing I need to show, when I could have done this first, is my amplitude. I start here at 0 at my midline. I go up to 1 and down to -1. So I do need to make sure that my amplitude is shown. But other than that, I'm pretty good. All right. Should we do another one? Yeah. Let's go back and we'll find another one to do. Let's see where I have my... we did 1 and 2. Which one do you want to try? Should we try 3? Let's look at 3.
You have to factor all of them?
Many of them, yes, you have to factor. It depends. Some of them, they might have already factored for us. Let's look at 3. What do you notice about 3 that's different from the problems we've seen? Anything occur to you that they have in 3 that looks a little different than what we've seen? There's no x, it's a theta. There's also no pi. What do they use instead? What do you think 30 stands for? Does it stand for 30 pi? 30 degrees. 30 degrees. So this one is actually in degrees. Can we do this in degrees? You bet. Do we usually? Not usually. So I'm actually going to ask you to take it from degrees and put it into radians. What would 30 degrees be in radians? What makes sense? 30 degrees, it's a little bit, 1/6. All right, so it's a small sliver. It's just 1/6 of the way to our pi. All right, so I'd want you, let's see if I can copy this. Oh, I'm going to get the same thing. Sorry. So I'm going to write this. I would want to write it as y equals negative sine of theta minus pi over 6 plus 4. I'm going to try to cut that. All right, give me 1 second here. There we go. So that's what we have for our problem. This is number 3. All right, that's our problem. Y equals negative sine pi minus, theta minus pi over 6 plus 4. Do we have to factor this one? Is there a coefficient? The coefficient is 1. So I think we're okay. Our k is 1 here. So let's work on the amplitude. What would my amplitude be? 1. We'll get into our, what do you guys have next? Period and phase shift in a minute. What is our vertical shift? 4. Okay. Period would be 2 pi. Our k here is a 1. 2 pi divided by 1 is just 2 pi. So there's a coefficient here of a 1. So our period is just 2 pi. Our phase shift, positive pi over 6. So let's talk about what the graph looks like. How did I get pi over 6? And why? Do you get why it's positive? All right. You don't know why. Okay, let's look at this. This is where I'm getting the y over 6 from, or pi over 6.
That's in number 3, that's 30.
Right, and I went through, instead of 30 degrees, I wanted you to put it into radians. Right, 30 times pi over 180 is? Right, math enter, enter puts it in a fraction for you, should get 1/6, right? Should, right? On a calculator. So what okay, let me go off to the side and show you what I did. So you're saying to me, wait a minute, okay, I had 30, I put it into radians just like you asked me to, okay? But you're dealing with decimals, and radians we usually try to deal with the fractions. So I'm saying this, let's just reduce this fraction, 30 over 180. All right, I got reduced those zeros. 3 over 18. Do you see how I got 1/6? Jonathan. We don't usually include the negative. The negative means that the curve is going to go down. It's an inverse curve. But the amplitude is always the absolute value. All right, so even when we're talking about amplitude is how much higher it goes, and it's a distance. So our amplitude is usually a positive because it's showing a distance. Okay? So with our amplitude, we start here at 4, but from that, we're going to go up 1 and down 1. That's the highest point and the lowest point that our curve is going to get. So that 1 was a distance. It's the distance from the midline that we're dealing with. Good point. So I usually don't include the negative in there. The negative is the shape of the curve, but it's not a distance. Okay? So the fact that my period is 2 pi, let's deal with that. That means that I have to get a complete cycle between pi over 6 is my starting point because that's my phase shift.